Well, good morning. It's so great to see you all here. My name is Diana Olick. I am CNBC's senior climate and real estate correspondent, which makes this doubly fun for me. And I'm thrilled to be joined by Michael Green, who is an architect and inventor of all things having to do with wooden skyscrapers, and Sandeep Nijhawan. Did I do it? Okay, yeah. Great. Who is CEO of Electra, which makes green steel. And we were supposed to have 4 people on the panel, but for various reasons I won't get into, they had to drop off. It was not me, I hope. But this, I think, is great because you tend to think of it as, okay, clean steel, wooden skyscrapers, should we put them in different corners and have them fight it out? But they actually have a lot on the same plate, so I want to get right to it. First of all, I want to go through each one just to explain very basically, and we'll start in the end, Sandeep. We say green steel. What is that?
Okay. Green steel, like everything green, is talking about essentially CO2 emissions. Okay, that's different than saying it's sustainable steel. So when we're talking about green steel, we're talking about solutions that do not use fossil fuel, predominantly fossil fuel, as an energy source to make steel, and shifting that to solutions, innovations, technologies that can and do not produce that CO2 emissions. Or
so
can
the steel
capture.
Is still steel, it's just made differently.
That's correct. So it's the same way. There's no green electricity, there's no green electron. It's the same electron, and it's just that in the process of making it, how do you get to it? You do not have greenhouse gas emissions.
And in the simplest form, can you tell us how you do that? Or is it proprietary?
No, it's not proprietary. I mean, there are, I would say, a couple of technology buckets to get to green steel. But to understand that, we have to just see how it is made today, just to set the stage. So the way steel is made today is we dig first dirt out of the ground. That's iron oxide. So that's iron and oxygen bonded together. Our planet is iron, so what's available on the crust is a mix of the two, which is iron and oxygen together. And steel is 98% iron. Okay, so to get to steel, first you get to iron, and the way iron is made is in a blast furnace. So you put that oxide of iron with coal, coking coal, heat it to about 1600 degrees C, melt it, carbon grabs the oxygen, which is now together with the ore, makes about 2 tons of CO2 for every ton of iron you make. And once you made iron, you again blend it with a little bit of carbon. And that carbon actually gives steel its structural strength. So when we talk about not having any CO2 emissions, we're talking about how can you reduce that oxide of iron into iron first. And you can do that with hydrogen. That's one way to do it. The second way to do that is any CO2 that's coming off the stack, which is quite hard, you can capture it and hopefully sequester it. This is the second way. The third way is another electrification way, which is what we are developing, which is to not melt anything, not use heat as a source of energy, but use electricity, where you first dissolve that iron oxide into solution. We do that at 60 degrees Celsius, just the way at the temperature the coffee is being made, and we extract iron through electricity to get pure metallic iron. And then we feed that forward into an existing steel making process. So thereby we do not have, as long as the electricity is green, have any source of carbon emissions. And we also do that with waste ores that are earth abundant, ores that are not available in US, for example, which are lower grade ores, and waste that sits in the mine today, and use the renewable electricity to get to clean iron.
Okay, so from the other side of the ring, wood.
Right, okay,
And I grew up in New York City. I know skyscrapers are tall and they need to be solid, and the idea of building one out of wood kind of terrifies me.
Fair enough. Let's get there too. So I'm an architect, and as an architect, basically part of my job is a little bit like shopping through a menu of different materials I can build with. And when you look at a menu, if we're eating as humans, right, there's food that's good for us and there's food that's not good for us. And generally the things that are grown by the sun are the things that are good for us. And it turns out in buildings, the exact same thing's true. So I'll describe, because Sandeep described the process. Wood is made when a seed is in the ground and grows into a tree, gives us oxygen, soaks up carbon from the atmosphere. When you take that tree and cut it down and put it into a building or a piece of furniture, 1 cubic meter of that tree is storing 1 ton of carbon dioxide. So now we have a sequestering vehicle that we can put into a building. Unlike any other material I can choose, I'm actually storing carbon. I'm using photosynthesis and the power of the sun to make the materials that we build with. The weight of buildings, the weight of materials is a big part of its strength. So one of the reasons wood is so strong is we used to historically take a big tree and cut huge beams out of it, but we no longer have those trees, or we want to protect those trees. And so now we take small trees, we glue together the wood to make it really, really strong. We're crossing the fibers in the tree, we're crossing the directions, making them really, really strong. We're making a product that's about 1/4 the weight of a steel product and about 1/6 the weight of a concrete. So when we make a building, it weighs much less. It's holding up much less. So the strength is actually, the strength of wood pound for pound is as good as steel. The difference is we're not trying to fight the forces of a super heavy building. There's a great, interesting way to see a concrete as an example, is that about 75% of the steel that goes into a reinforced concrete building is just there to hold up the weight of the building itself. It's not even there to make the building. So right now, all over the world, we're making buildings by just throwing materials at them because they're so heavy. And so wood has this incredible inherent strength because it's engineered. It's actually very predictable, and we can build very big buildings with it.
Now, let's get into cost here, though. So in the steel side of it, when you're making this, you're using a lot of electricity, obviously more than you would if you're doing it with coal. You need to get that sustainably, and to scale this, what are the costs involved comparatively to traditional steel?
So traditional steel, depending on what type is, crude steel could be almost like $500 per ton, let's say, call it an average. That, by the way, on a scale of any other metal we look, it's actually the cheapest you can ever get to in a price point, and that's why it gets used a lot, because it's very, very cost effective. All the predominant paths that we are looking at today is likely going to increase the cost or the premium to that product, maybe 25% or so more than that. And what we are trying to do is not get there, because the point is that if you increase the cost of something that is as foundational on which the modern society is built, it's going to massively deaccelerate the transition to getting there, okay? So we are trying to get to the same parity with incumbent steelmaking process, Diana, without, by not increasing cost. And there are two levers we pull. One is around the ores that are waste today, so there's no real value of anybody has. It's fascinating to think about that. If you move 25 million ton of, let's say, ore in the mine to make steel, for making steel, you actually move about 5 times that material in the mine itself, which just sits there, and it's not of high grade. It is actually of waste. There's a lot of stuff that has already been dug out of the ground that is just sitting at the waste, and we are trying to use that along with renewables that are the intermittent renewable, not the baseload renewables like nuclear, intermittent renewables that are the cheapest form of electricity that is going to be green for a while to come. So combining those two together in the process lets us to get to something that is very cost effective.
But it would need to be at scale, and what is it going to take to get to that level to bring the price down?
Yeah, so I mean, just so that everybody understand, steel making is not for the faint of heart. I mean, just so that we understand that point. We make 2 billion tons of it a year, which is 20 times larger than any other material we produce in the world today. Okay, that's by far the largest material that gets produced. On a per capita basis, we're talking about 8 billion people. Each one of us in this room is at least consuming 250 kilos or 500 pounds of steel for our daily lives. That doesn't include 80% of humanity that doesn't have what we have in this room. So we are consuming a lot of, which we don't see into that. So it has to be done at a scale, no doubt about it. A small steel mill, if it is electrified, what we're talking about gigawatt of power. Okay, so the amount of electricity and energy intensity needed is large, for sure, and it falls into the same category of decarbonization thesis that if it's all about electrification, and if you can make something electricity green, and if you can get the process electrified, that's the path to doing this at scale. Okay. Having said that, anything we do to reduce the consumption of something as large as this, which is what Michael is talking about, is a winner. Because if you... 50%,
so you want him to put you out of business?
Yeah, I mean, absolutely. One of the advantages of steel is that what we also don't realize is that it is the most recycled product in the world today. Okay, we recycle 500 million tons of steel every year, and it is so predictable that when this building will go down, not concrete, but the steel is going to get recycled. And the industry can predict which building came off 30 years ago and when the steel comes back into the circulation, actually. It is that advanced, at least in the North American context. So it has lots of advantages to that, but the Achilles heel of all of that is it requires energy. It is energy intensive process, and we can't cheat there. That's basic science. That's thermodynamics. So it requires energy to do that scale.
So let's get into the financials of wood. To create this, and am I wrong in calling it a composite the way you describe it? What do you call it?
So we're going to call it engineered wood. That's
engineered
probably
wood.
or mass timber. That's the kind of hot word version.
What is the cost differential compared with traditional?
So a couple things. One is we use steel, just a little bit of it, to do the wood buildings. We use concrete for the foundation. So we're just changing the proportion of what we use in any building, and that's typically how it works. What's really surprising, I think, for a lot of people to learn is that different cities around North America have different cultures around the material they use. Some cities are steel cities, some cities are concrete cities. And it's interesting how that's evolved. And so when we look at the prices of any building, if you're in a concrete city and you want to do it in steel, it's going to be expensive. So I can't. It's all often really hard to predict in which market the best price choice is going to be.
Permitting that you say there's a concrete city and a steel city?
It's really a cultural issue. So the contractors start this kind of historically it started in concrete. The towers started becoming concrete. I live in Vancouver, Canada. We're a concrete city. Seattle's 2.5 hour drive. It's a steel city. And that's just culturally how the contractors got used to building, and so they tend to continue to build that way. What that means, though, is that cost for concrete where I live is quite inexpensive to build a tall building because the contractors are really good at it. And so I can now build a wood building where I live at the same price as a concrete building. We just don't really have steel buildings because our culture has never really developed it like Seattle. And vice versa. Seattle's now starting to do a lot of concrete buildings, but they're quite expensive because they don't have the skill set to do them well. And so wood can be the same price as concrete in Seattle. Every city's a little different. New York's much different. Trade unions and all kinds of other issues influence the price. And so generally wood, steel, concrete are all competitive. But there's a nuance of where you're talking about to figure out what's the most competitive price it's going to be.
And so the engineering of the wood doesn't cost more in the process, et cetera. But since I brought up permitting, that's obviously got to be a big part of it. And you were telling me before that it's just been permitted in various places.
Yeah, it kind of drives me crazy because I was just in New York a week and a half ago walking around in Soho, and you look up, and I was with my son, and I kept saying, that's a wood building, that's a wood building. These are all 100-year-old wood buildings that are 7, 8, 10 stories tall. We used to know how to do this, and then we created building codes that forgot how to do this, because steel and concrete are great materials. They're non-combustible materials, and so they're great materials, but we just didn't understand, of course, 150 years ago when we started using them so much that they had such a huge energy and carbon footprint. Now we do. So now we're back into this conversation of how do we choose materials with lower carbon impact. And so advocating for wood meant that the first building I was doing, and the way I first developed this way to build skyscrapers, the building codes didn't allow it. I'm fortunate to live in British Columbia, where my government said, don't worry about it, we're going to work with you outside the building code to build the first one as a pilot project. And that tipped the building codes where I lived, that tipped the building codes in Canada, that tipped the building codes here in the United States. So here you guys can now build up to 18 stories in wood, whereas 3 years ago, you could only build 5 stories in wood. And what I was mentioning to you before is that building codes they're not science-based. You would think they would be, but they're really not. They're lobbyist-based. And so there should be no, in my opinion, and we saw this yesterday, and I think in your forum, I think Chris was saying it actually, is that permitting and the process of the length it takes for some of these big projects to happen is the same in buildings, and the building code being so restrictive is limiting our ability to innovate. There's no height limit on steel, there's no height limit on concrete, but there is on wood, and there shouldn't be, because it's actually creating this artificial ceiling that's limiting our ability to truly innovate. That's because the building codes are going to evolve very slowly, and they can't. They need to actually accelerate that change. Buildings need to be safe. People can die if we don't do buildings well, but we also need to go much faster in the way we both permit buildings and also the way we evolve the building codes.
You mentioned combustible. You used the word. I think of a wood building, I get concerned that if there's fire, and especially in the West where we see more and more fire, are these as safe as a steel and concrete building that is non-combustible?
Yeah, so all three have to behave ultimately from a safety point of view the same way. So when we design buildings, they are designed for the amount of time it takes for somebody to leave the building safely and for the firefighters to safely fight the fire. So they're either 1 hour or 2 hour construction is what they're called. So a wood building has to live to that same standard as a concrete or a steel building. As sadly we know from 9/11, steel buildings, when there's a lot of heat, they collapse catastrophically. Wood buildings, when the wood is massive, so don't think about this like a 2x4. If most homes in North America are built in wood studs, 2x4s. This is massive amounts of wood glued together. Because of that, it's a little bit like if I handed you a log and a match and said start a fire, you can't do it, because the mass of that log just won't catch fire. These buildings behave the same way. And then if they do catch fire, it chars on the outside. And much like if there's a forest fire, big trees survive and live on for hundreds more years. It's the charring actually creates a protective layer that's actually a fireproofing layer. And so we design knowing that char, we overbuild the wood a little bit, knowing that if there was a catastrophic fire, the structure would still be strong inside that char layer. And so the techniques are all science-based and very, very reasonable. And these buildings actually just don't catch fire.
How tall can you build?
Legally or there's no limit.
Structurally, there's no limit, but legally there is.
So building codes, as I've said, they've changed in China, they've changed throughout Europe now, really because of the stuff we were doing in BC. And the code does limit us. The tallest building right now is 30 stories in Vienna. We've designed 34 in Paris, but not yet built it. But we know we could have built the Empire State Building. If you saw my talk the other day, we know that we could build, probably any building this way. I just don't actually think we should. It's a lot of excess wood to do that. And ironically, as much as I sort of have become well known for wooden skyscrapers, I actually don't really believe in skyscrapers. I don't think they're actually a healthy, productive part of building communities.
And you got on this panel because...
Yeah, exactly. So the reason I've advocated for them is you change the world by, aiming for the moon, not aiming for, the sky. And I often reflect on the story of the first skyscraper. The first skyscraper was built after Otis invented the elevator in Chicago and was introduced to the World's Fair. And the first tower was only 10 stories tall, and it was wrought iron. And people were terrified to walk underneath the building. They just were terrified of 10 stories, which is just hard to imagine today, right? But I knew with the way we were introducing wood, if we wanted to build a whole lot of 12-story buildings, start talking about 18 or 30 or whatever, and build a few of those. Because then all of a sudden, public perception of what's possible changes. And so you need to actually engineer the extreme in order to make everybody comfortable with this new way of building. It's the first new way to build a skyscraper in 150 years. And we needed to completely reframe the way people thought about it by showing that you could do big. I don't personally think tall buildings create good social connectivity, and that's actually why I don't, I'm still an architect and really think about those things as well in the way I build. So,
interesting. Sandeep, I want to get to investment because I work at the Business Channel. In order to scale this, how hard has it been to get investors on board with this in order to have not only Electra grow, but other companies in the space go to green steel?
So, I think I've been doing, startups for now 15, going to 20 years. So I've been in the space of startups and venture investments for a long time. By the way, I'm not a steel maker. I don't know how to make steel. I'm an entrepreneur. I look at problems and look at solving problems. What is very unique that is happening, I think, right now and started maybe a few years back is that for the first time there is money. There's money coming from a lot of different entities to support it, now including the government. So for us, we are only 3 years in existence. When I started the company, didn't have any idea how to do it. It was a PowerPoint vision, let's put it this way, that if we could do this, would this be enabling that we could get to green steel the way what I'm talking about, using waste and intermittent electricity? That would be quite enabling. And so far, in less than 3 years, we raised $85 million. Okay, and we're building our first pilot right now in Boulder, Colorado. Where is this money coming from? We are led by Breakthrough Energy Ventures, which is Bill Gates' funded venture capital firm. We have 6 financial investors who each have at least $1 billion or more to deploy into things that are all things disruptive related to decarbonization, energy transition. We have 3 strategics. Nucor is a partner, which is the largest steel maker in the United States, with, by the way, the lowest carbon intensity in the world in terms of the steel that they produce. We have a mining company, BHP. We have Amazon. Amount of steel that they consume for their operation is just massive. So there's lots of investments coming. There's lots of private equity that's coming earlier and earlier in the stage, because what I hear, and which is true, is that there is lots of constraints of good deal flow, where these are very risky things that what we're talking about. It's a high risk, high reward, but if you're going to be successful, it has to be big. So in terms of these private equity is coming quite early in the game, where they used to come at Series C and D. They are starting to come at A and B even in terms of early stage investments. With the investment from the government throughout the, I would say, technology evolution from early stage innovation to Office of Clean Energy Demonstration, OSAD. By the way, yesterday, $6 billion DOE, OSED announced $6 billion DOE grants, these are grants, for industrial decarbonization. Okay, $6 billion that just came out yesterday. So that's just OSED. Then there is LPO, which has another 60 billion plus to deploy. And then there is IRA and production tax credit, investment tax credit. So there is, for the first time in my history of doing clean tech, hard tech, there is support across the value chain, which is quite unique. There's never been a better time to do innovation in this space.
And are there others doing clean steel in the same way that you are? What's your competition in the space?
Our competition looks like, by the way, unlike cement and lots of other things there for every company or DAC, there are like hundreds of companies trying to do. Steel is actually hard in that sense. It's hard to bait and it's hard. Our competition looks like either you believe in carbon capture, okay, and that's really some very large industrial conglomerates trying to do that. Or you believe in hydrogen, so you are on the hydrogen gravy train, and hydrogen is solution to everything. So you believe in that, or you don't, or you believe somewhat skeptically that can be done. And there's a place for that. And then it is two other ways to using electricity extract iron. So that's one of them is us, and the second one is Boston Metal. And then there's a cliff. I mean, it's really, we're talking about 3 or 4 buckets here. It's not like CO2 capture, and there are probably 300, last time I counted, startups trying to innovate in that space. So there is a lot of very few innovation levers here to sort of attack this problem, unfortunately.
Yeah, I asked this because I don't know, I heard yesterday, and I have not confirmed this at all, but that 50% of VC money now worldwide is going into climate-related companies, climate startups. And it was interesting because 2 years ago at COP26, when I was there and there were a lot of CEOs from companies all around the world, it was big business footprint there and a lot of VC, a lot of hedge funds, et cetera. And what they were all saying was, you know, you're watching governments contribute billions, really private capital will put trillions into climate, and that's where we need to be focused. And that's why I asked the questions of competition in the space, et cetera. You know, we do at CNBC, we do a series called Clean Start, and we look at the venture capital going into these startup companies anywhere from 10 million to 100 million. So congratulations on yours. That's very
Thank you.
Excellent. We work with Breakthrough Energy, of course, and other like Khosla Ventures, and there's a lot of increasing competition in this space. So I would ask you, Michael, the same thing. Now I know you're not running a startup, et cetera. You're more on explaining how it works and the technology and the architecture behind it, but you must see the investment. Mm-hmm. Is there enough investment going into engineered wood?
I also have a startup in that company I talked about the other night. So the interesting thing, the important thing to remember is that in the next 40 years, we're going to double the footprint. The number of buildings on the planet are going to double. This is the largest economic engine, I think, that exists. And I think McKinsey had a report that said a couple of years ago, it was sort of like $800 billion a year spent in the U.S. on car industry, and $900 billion a year is on tech, and 1.2 trillion is the building industry. It's also a place, besides in the big materials, which would be really steel the biggest, it's a land of mom and pop shops. There's no Ford motor car company of building industry. Turner Construction is the largest construction company in the United States, and it's still a relatively small company. So there's not a lot of R&D. What that means, it's also that, to me, it's the largest investment opportunity, regardless of climate, because we need to meet this human need, and we also need to do it in a green way. And so innovation is the only way we're going to do that to meet the scale of this. And this is by far the biggest problem to solve. It's, of course we need to solve, energy is a huge part of that, but how we make buildings, what they're built out of, is actually going to drive an enormous amount of the global economy, and we don't really talk about it properly. So that's why VCs, even outside of climate, are really shifting their focus, because if you're sitting in Silicon Valley in a restaurant, every conversation's about some tech startup. And if you're sitting at a construction industry conference, not a single conversation is about innovation or startup or something. It's just sort of, it's not the land of innovation, which means it's the land of opportunity. And that's, I think that's starting to change. The VCs are starting to shift to thinking about buildings, not just about green, but also about affordability and the speed of construction, and shifting into being a manufacturing process in the way we build. So taking it, we still build in an incredibly primitive on-site way. So we're, until fairly recently in New York City, if you were forming concrete, the Carpenters Union controlled how formwork worked, which meant they had to build it on site. So way up in a tower, somebody's swinging a hammer making formwork. It's insane, right? It's so old school. And all of that is ready for disruption.
And we're seeing that in some of the warehouse-built, prefabbed, modular homes, et cetera. There seems to be big growth in that.
There is, and there's real quality issues as well, but absolutely. And our systems, our building codes don't know how to deal with that. Or, across the United States, building inspectors come and look at whether your building's well built on site. They don't know how to do it in a factory. And so that's creating all these other challenges that government needs to lubricate in order to move us forward, because off-site is inherently uses less resources, is much more efficient, actually can improve quality, but we're not seeing that yet. So there's a lot of investment in off-site's become really important. And we'll continue to see it. So. And
I should have started with this, but you can tell everyone what exactly is the scale of carbon emissions of construction in this business, because I don't think a lot of people realize. We think of cars, airplanes, whatever, as the great offenders, but real estate.
Yeah. So so in the United States, it's about 47% of man's greenhouse gas emissions it comes from the operating and making of buildings. 47% cars. And worldwide, it's 39%. All transportation combined is about 23%, and all industry is about 30%. So buildings are the number one driver of the climate conversation. Now a huge chunk of that is heating and cooling, which comes down to energy, what renewables versus non-renewables. But the other chunk of that, about a third of that, is entirely based on these material conversations we're having, and this is the classic, you guys know, in the climate space, this is the classic yes and. So I am a huge fan of steel that's green, and will be a champion of what Sandeep's doing, because we need what you're doing desperately, and we need what I'm doing desperately. Everybody that's coming with innovation in this space needs to be supported, and they need money. But we also need to reframe the conversation to show why it's an opportunity. I think if you don't understand that as an entrepreneur or as an investor, you're almost grossly negligent as a professional not to realize this is the single best investment opportunity probably in human history.
Write that down. I kind of wish we had a third chair, because we have steel, we have wood, and we should have concrete here. I'm curious what both of you think, and Sandeep, I'll start with you, because we've done a bunch of stories at CNBC on this just because everybody loves it and it's very clickable. 3D printed houses, 3D printed buildings. Okay, I roll. Sandeep first. Okay. What do you think of that? Obviously, you can't make them out of steel. They're made out of, supposedly clean concrete, and they're supposedly cleaner in construction. They take a lot fewer people to build, the smaller carbon footprint, and they are also more sustainable and weather resilient, from what I'm told. Thoughts?
I think the way I think about it is that if you are doing 3D printing, I think of that as you're engineering something at an atomistic level, okay, and you are doing that really in time. And so I think about it as that if there is a way to create more engineered products, I think there is a benefit to it. We didn't talk about using carbon actually in buildings, even because of the weight. If the goal is to reduce weight, one other material that is besides wood is actually if you can use more synthetic carbon in the material, that can also help. But I don't see how 3D printing can solve the problem entirely. I think it can be part of the solution to getting more engineered material, if at all.
You rolled your eyes.
Yeah, it drives me crazy. It's if you're super wealthy and you want a nice backyard shed, get it 3D printed. It's not going to address where people live and how people live globally, and it drives me nuts that we pay attention to it to the extent we do, because it's not going to solve the big problem, and it's distracting us from the things that will.
But their argument is that it's cheap to build, and we can build affordable housing and go to different countries and get people homes where they never could before.
So it requires
just plain devil's advocate.
Yeah, it requires. So there's a bunch of things. First of all, it's concrete. There are ways to do it. There's some cool stuff in mud and seed and ways of doing it in a better way. So there are some cool technologies that allow for 3D printing, and it will have some degree of role. But the problem is you have to take the 3D printer to the site. And that's just not realistic in so many places. So if you have a perfectly flat site, nothing around it, but you can put that machine there and 3D print the building, sure, out in the middle of a field. But that's not the way the world works in building, right? It's a tight city street that you've got to get a machine down, block off the roads, get down a lane, get that machine in there to 3D print the building. The building is uptight to its next door neighbor and, has an inch or two between it. That 3D printer can't print an inch or two away from another building. It's just not, the people pushing that don't build buildings. It's just not the way most buildings
But
exist.
for single family housing, it would be more viable. If you're going out into the
theory.
exurbs.
Yeah, which we actually should be working to not do, because those
You need cars to get there.
You need cars to get there. When buildings are tight against each other, they actually insulate each other. Row housing's amazing, efficient. You barely turn your heat on because you're getting it from all your neighbors. Single family houses have a huge carbon footprint for a whole bunch of reasons. And so then adding 3D printed concrete is just making it worse to me. And so, I think that it's an interesting, fun thing, but what I really worry is, it's distracting us from true innovations, and it's making people think this is a solution. If you were at my talk the other day, the reason I say buildings are not sustainable is because I'm worried that when we say I live in a sustainable building or I built a sustainable building, we're convincing the public that that's good enough, that we did it. Great. But we are so far from true sustainability in buildings, we shouldn't be described that way. We're trying to be more sustainable, but we are nowhere near sustainable. There's no such thing as a sustainable building because there's so much wasted material and non-renewable in all buildings today. And so we have to be careful of how we promote what innovations are actually solving the world's problems and what are just fun to talk about. And that's how I feel about it.
Well, it was interesting from last night's panel that they talk about how we're trying to electrify everything, and we're trying to, make that as the great form of energy rather than coal. But with that will come massively increased electricity use, which we're really just chasing, because sure, you can get some for solar, wind, et cetera, but not nearly enough to scale. So are we kind of, shooting ourselves in the foot with that? Or...
I think that's a very good question, because you're right. We're chasing electricity for a lot of things, and just to put that in perspective, if we were to electrify steel making, all of it, we'll have to increase the grid by 30% entirety in the world. So it's a massive increase, and that is just for steel. That's about 7% of global emissions. The way I think about that is, especially with respect to steel, Diana, is that the challenge we are facing today is with our infrastructure of grid not being there. It's not that we cannot deploy the renewables or that we don't have the renewables to deploy. It is just that the speed at which we can deploy is a problem, which is related to one around codes and permits, and the other side of that is our grid is not there to support it. And when I think about that, I come to the conclusion that we have to develop, and I'm talking now about industrial processes, not about skyscrapers here. We have to develop manufacturing processes and industries that do not assume that electricity is a commodity that is green and is available 24/7. Okay. And what I mean by that is, if you're trying to displace coal as a source of energy, you're really talking about an energy source that has to be sub $20 a megawatt hour. It's not 50, it's not 60, it's not 100. Okay, because if you start with that assumption, you actually will never get the economics to work. This is as simple, because you're trying to displace coal as a source of energy. So what that means is that there is only one source of energy today that can do that, and that's renewables. We believe at scale we can be at sub $20 a megawatt hour. So what that means is that if that's the thesis you start with, then how can you develop industrial production of materials and whatever we need to make green, where that attribute, which is intermittency of renewable, is a feature and not a bug? Meaning that if you think about hydrogen, you make hydrogen when electrons available that are cheap and green. You shouldn't make hydrogen 24/7. If you're doing that, you're not doing service. It actually is going to increase more carbon footprint. Actually, it's a risk of producing more carbon footprint. So you have to you have to pair these global, big, energy-intensive industries with manufacturing processes that can follow the availability of that electricity, so you can load follow, so that you can basically make steel when that electron is available. You shouldn't make steel when that electron was not available and that was not renewable. So it's a paradigm shift of how we have to think about, and that's to address the constraint that I don't believe that we will be able to solve the grid infrastructure problem in any time soon in the next 15, 20 years, even if we tried.
I think when Chris from Engine One talked about that last night, what that's really about is relates to that change, globally change, with developing countries becoming developed. And that's really why our energy grid is going to grow. It's not going to be the Internet of Things. It's going to be the fact that just billions of people are going to come from living in slums into, currently about 1.2 billion people in the world live in a slum. They're going to move into proper buildings and have lights and electricity to run those buildings. And so it's global population change is what's going to drive that energy that we need. We want people to be risen out of poverty, and that is happening. That also means more electricity globally. So that's the big engine of global electricity. I think certainly things like what you're talking about with steel is a huge part of it. And that's the challenge, right? So many of the things that we talk about around climate at conferences like this are very much about how we live, but not how the world lives. And we need to solve the world's problems, because this is, as we all know, is a global problem. And in the building industry, could not be more true. The vast majority of buildings are not going to be here in America or in Canada where I live. It's going to be in developing countries, right? It's going to be a population explosion in Nigeria or India or, or Indonesia. So, and so then we need to be thinking about how these technologies are really employed in places that are not necessarily going to have all the luxuries of the things we have, but have a much greater need. 100 million people in the world live homeless today. Half billion people live, with floors that are dirt in parts of the world, and so that's the change that's coming too.
May I add to
Sure.
that?
And then we're going to get to questions, because
I completely agree with that, because if you're trying to solve this footprint problem, and we didn't talk about steel, 7% of emissions, half of it is made in China today, using coal-fired blast furnaces. The next biggest place where this growth is going to come from is in India, which is still building. I won't name the companies that are building the blast furnaces in India. It's still circa 2023 till 2030. There is a race to build blast furnaces in India right now. We are actually doing it as we speak, okay? And my thesis around all of that thing is that if I look at the raw material, which is I need to make that kind of a global material that drives the modern society, which everybody wants to uplift humanity, you need ores, which are lower grade. The whole world has that. There's nobody who has actually supremacy on that. Our planet is actually iron and It's everywhere. So you have that, and then you need the renewable electricity. You actually don't need the grid. It's a false thinking that at that scale, the electrons are going to go into the grid and then going to come somewhere else off the grid. And if you're going to think like that, you have constrained this thing. You're never going to be able to solve it. And if you want to make that level of impact, you have to think this outside of the way the world exists today at that scale.
Now for the tough questions.
Hi, my team was behind the first tall mass timber building in New York City. So as a result of that work, we're up to 85 feet in New York. The question is to both of you is, who are the decision makers on the sales conversation? Who determines these big material selection in your respective industries as you look forward?
Yeah. So typically, it's either private developers who have their formula of how they build buildings, and they're either open to trying a new formula or they're just going to do it the way they've always done it. Regulation will help them decide what they do. Where I live, there's going to be mandates on embodied carbon in buildings, and that's going to effectively flip our entire industry to wood, or like our entire tall building industry will go from concrete to wood just to meet the embodied carbon requirements. But Vancouver is a pretty progressive place. That'll take a while, especially down in the States, to happen. So it's going to be developers seeing a market difference for them to choose a different material, and that's certainly my client base, who are progressives that are looking at clients and renters or buyers that really want to be in a more sustainable building. On the public sector side, which is a huge engine for building, and certainly institutions, universities are really moving this direction quickly because they have a much greater motivation to decarbonize. And so I'm seeing a huge shift towards mass timber and wood in the institutional public sector side. So I'd say those are the things. And part of the responsibility we have is making sure that we build something that the market wants and that we're cost effective. At the end of the day, nobody really pays more for anything. They just want the best value as well as, ideally, something more sustainable. Yeah.
Hey there. Mostly for Mike, I think only for Michael. I work in green building, but smaller scale than all this stuff. And, health has become a bigger and bigger factor. You went this whole talk, I think, because we're not in the right place. So you didn't say, how beautiful mass timber is. Are you or are other mass timber thinkers and architects starting to smuggle in beauty as a health benefit?
Not beauty, but actually, so all the science shows us that when you're surrounded by natural materials, by the way, none of the materials in this room are natural, we are inherently we have less stress, and that results in better health outcomes. And so I don't get to talk about this publicly too much yet, but we just built a couple of really big mass timber buildings for Google on the main campus in California, and with them, we did a whole bunch of really interesting research. And part of it was, not only do you feel less stress around natural materials, and wood being one of them, but you have less sick days. You actually have increased work productivity. We are putting this into schools. People learn better and when surrounded by natural materials. We're putting it into health care, and because people actually heal quicker. If you just put a photograph on the wall of a tree or the wilderness, you heal quicker. It's pretty amazing, and all of that evidence, thankfully, is starting to show up in studies, and it makes sense, right? As a species, we haven't somehow super evolved in the last 150 years to be surrounded by all these artificial materials. We've always historically been around natural materials, stone included. And of course our bodies are reacting to it, right? Like all of us have lived through sort of asbestos was great, and now it's not, and all these materials that we think are great, and now they're VOCs in the carpet. Now let's get rid of those, and so we've we've realized, why are kids more allergic to things than they ever were before? Why are we having all these weird new health issues? They are very much related to buildings, and a lot of things we just don't quite know. But I guarantee that natural environments are going to result in better health outcomes.
Sandeep, I'm really interested in this idea of doing steel production when the electricity is cheap and green, and intermittently, as you put it. So I got kind of a two-parter for you. One is, what lessons do you have to learn from other industries that are doing that? Like you mentioned hydrogen, but also I think about crypto mining, where we hear about this, which is maybe not the best example, but like that is what they do. And then the other side is, how do you have employees work on that? If you show up to work and like you got to go home 2 hours later and then you come back, and how does that work?
In terms of where the production is, the second part of the question.
In terms of if it ends up not being cheap, like if the intermittency, exactly. If the sun doesn't shine or the wind doesn't blow that day.
Okay. So let's sorry. Can you remind me the first part of the question? I lost thinking of this.
What do you have to learn from other industries?
Oh yeah. So thank you. So we actually, I think this is what I'm talking about, and simply is what you will call demand response. Okay. It's a behavioral change. We actually have been teaching consumers. Utilities have been teaching consumers that don't start your washing machine when the price of electricity is high and all that stuff. It's a behavioral change of how we think about electricity. We have been taught, and the world has been taught, that electricity is a commodity that's just available. When you flip a switch, you demand that the light has to go on. And we have been slowly shifting that. Hydrogen is an example of that you build this energy carrier on using green electricity when it is available. So there is a lot of other fundamental things that are happening, very similar to, you can talk about Google moving data and following the sun, from the data centers where their energy consumption could be. It's just demand response in the simplest sense. That's first part to your question. So to me, it makes a lot of sense. The second part of the question, as much as there is intermittency, when you build this thing at scale, what you will find is that it's quite predictable, actually. So it's because you're not going to go do, even if you had a wind farm, it will, at that scale, it is like 10,000 acres of what you're talking about, and you're aggregating that electricity. So it is quite predictable, and the seasonality is quite predictable in terms of its variation. But that's what I'm saying, is you have to build a factory that accommodates that feature, meaning that it has the ability to ramp up and ramp down production for the basis. And if you're worried about labor is such a small portion of that cost that even if somebody was twiddling thumbs for 3 days, it actually will not be it will be zero error in the system, because for these kinds of highly energy intensive industries, 60 to 70% of your cost is burdened in the cost of electron. Everything else is secondary. So it's designing that type of a manufacturing process where it's a feature, as I said, and it is tied to that. And a lot of it could be artificial intelligence. It can be added in because we can predict how things are going to shape. The profile is going to shape in the next 3 days of electricity generation if it's renewable air and these things. You can predict this thing as well.
Hi, thank you so much. My name is Alize Carrere. I'm a PhD candidate here at the University of Miami, and I'm studying a lot of these sort of wood building practices. And I actually grew up in a treehouse in upstate New York that my father built. He's a wood home builder. And the question I have for you is specifically about the use of of other wood-based materials and building panels that are being proposed where you fill them with straw or agricultural waste. It actually came up, I think, in one of the plenary sessions, using, waste from forests and packing it into modules, I guess, in order to build. And I'm curious what your thoughts are on that in relation to this landscape of wood home building.
So that's definitely a yes and. So we need to do that. We need to support all sort of bio-based solutions in building is the way I see it. And there's a lot of cool ideas out there. There's a couple guys that started a company called Plant D recently. They came out of SpaceX and they started this startup taking, instead of what's called oriented strand board, which is wood flakes, basically. We've all seen it. It's like a plywood that's made out of wood flakes. They're now doing that in grass instead of trees. And those are the kinds of innovations that are really meaningful and we should be supporting. There needs to be millions of these innovations. The sort of number one goal I have right now outside of running my practice is to really promote this idea that we need to move to a massive number of different types of biomaterials, and some are going to survive and some will fail. There's durability issues, there's weathering issues, there's flammability issues, there's a lot of technical issues, but we're also making huge headways in this. And what's important is that, when it goes back to the cost of buildings, when steel, as an example, when you want to build a steel tower, it's a global market. If China's building a ton in steel prices are outrageous, and you just can't build in steel. We need to not think quite so globally about how building materials work. If they can be more regional, there's enormous climate benefit from that because you're not transporting, but there's also a lot more price stability in that. And these biomaterials give us a chance to be much more local. When you're shipping steel across the ocean all the time, it's obviously not a great solution, whereas biomaterials give us a much, much more regional and local opportunity to build.